Water. It's everywhere on Earth. Covering over 70% of our planet's surface, it shapes our landscapes, influences our weather, and sustains life as we know it. Oceans, rivers, lakes, even inside of us. Water is the lifeblood of our world, coursing through every living organism, from the tiniest microbe to the largest whale. But have you ever wondered where it came from? How did this essential element find its way to our blue planet? For a long time, scientists thought water arrived on Earth late in the game, delivered by icy comets or asteroids. These celestial bodies, rich in water ice, were believed to have bombarded the young Earth, bringing with them the precious liquid. But now, we're discovering a much more fascinating story. New research and advanced technology are revealing clues that challenge our previous understanding. Recent discoveries are pushing back the origin of water, way back. Scientists are now tracing the history of water to the very beginnings of the universe. Imagine a universe still in its infancy, a time when galaxies were just starting to form and the first stars were igniting. That's when scientists now believe a good chunk of water was born, billions of years before our sun even flickered to life. Water molecules formed in the cold, vast expanses of space long before our solar system came into existence. This isn't just some cosmic trivia, it's a revelation that reshapes our understanding of the cosmos. Knowing that water is older, more fundamental than we thought, changes our understanding of how the universe, and everything in it, came to be. It suggests that water, a key ingredient for life, has been a part of the universe's fabric from the very beginning. So, buckle up, fellow space explorers. The story of water is not just about our planet, it's a tale that spans the entire cosmos. We're about to dive deep into the amazing story of water, a tale far grander and more ancient than we ever imagined. From the depths of our oceans to the far reaches of space, water's journey is a testament to the wonders of the universe. You might be surprised to learn that water isn't that rare in space. In fact, it's more common than you might think. It's actually forming all the time. The universe is a vast and dynamic place, constantly creating and destroying elements. How? It's all about basic chemistry, just on a cosmic scale. The same principles that govern reactions in a lab on Earth apply out there in the cosmos. The recipe for water is simple: 2 hydrogen atoms and 1 oxygen atom. This combination forms the familiar H2O molecule. Hydrogen is the most abundant element in the universe, floating around since the Big Bang. It's everywhere, from the smallest particles to the largest gas clouds. Oxygen, while less common, is also found in vast clouds of gas and dust scattered across the cosmos. These clouds are the birthplaces of stars and planets. These giant clouds, called nebulae, are like cosmic cooking pots. They contain all the ingredients needed to form new stars, planets, and even water. Inside, temperatures can plummet to hundreds of degrees below freezing. These extreme conditions are perfect for the slow dance of atoms. When hydrogen and oxygen atoms collide in these frigid conditions, they slow down enough to bond, forming water molecules. This process is slow, but steady, happening over millions of years. These newborn water molecules, however, aren't the kind we'd recognize. They don't form liquid water like on Earth. Instead of liquid water, they exist as ice, clinging to dust grains in these vast interstellar clouds. This icy form of water is crucial for the formation of comets and other celestial bodies. So how do we know that water is older than we thought? Scientists have been busy looking back in time using powerful telescopes like the Atacama Large Millimeter Submillimeter Array, or ALMA. These telescopes can detect faint signals from molecules billions of light years away. And what have they found? Evidence of water in some of the earliest galaxies ever observed. These findings were a game changer. They meant that water had to be forming much earlier in the universe's history than we ever imagined. But the surprises didn't stop there. Scientists also discovered massive reservoirs of water vapor surrounding quasars, incredibly bright objects powered by supermassive black holes, billions of times heavier than our sun. These discoveries provided further evidence that water was already abundant when the universe was still young. Imagine the early universe just a few 100 million years after the Big Bang. It's a hot, chaotic place filled with swirling gas and radiation. Not exactly ideal conditions for water to form, right? But even in this extreme environment, small pockets of cool gas existed. These pockets, shielded from the intense heat, provided the perfect conditions for hydrogen and oxygen to meet and bond, creating the first water molecules in the universe. Over time, these early water molecules began to clump together, forming icy dust grains. These grains, like tiny seeds, would eventually play a crucial role in the formation of stars, planets, and ultimately, life itself. Section 5. Stellar nurseries, water and star formation. Fast forward a few billion years. The early universe has cooled down, and those icy dust grains we talked about, they're now clumping together in vast clouds of gas and dust, the same nebulae we met earlier. These nebulae are like stellar nurseries where new stars are born. Gravity pulls the gas and dust together, causing the cloud to collapse and heat up. As the temperature rises, the icy dust grains sublimate, releasing their trapped water vapor into the surrounding cloud. This water vapor plays a critical role in star formation. It helps to cool the collapsing cloud, allowing it to fragment and form multiple stars, instead of just one giant star. Without water, our sun and its planetary system might not exist. Section 6. Planetary systems. Water's role in their formation. As stars are born, they're surrounded by a swirling disk of gas and dust, leftovers from the star-forming cloud. This disk, called a protoplanetary disk, is where planets like Earth are born. Remember those icy dust grains? They're still hanging around in these disks, carrying their precious cargo of water. As planets form, they sweep up the surrounding material, including these water-rich grains. This process is how Earth got its oceans. Early in its history, Earth was bombarded by icy comets and asteroids, delivering vast amounts of water to our planet's surface. But we now know that a significant portion of Earth's water was already present in the building blocks of our planet, thanks to those ancient water-rich grains. Section 7. The significance rewriting our cosmic history. The discovery of older-than-expected water has profound implications for our understanding of the universe. It tells us that water isn't just a rare fluke, but a fundamental ingredient in the cosmic recipe. This discovery also challenges our assumptions about habitable planets. If water is as common as it seems, then the ingredients for life as we know it may be more widespread than we ever imagined. Furthermore, understanding water's journey through the universe helps us trace the origins of our own planet and the life it harbors. It connects us to the cosmos in a deep and profound way. Section 8. Our water ourselves. A deeper connection. The next time you take a sip of water, consider this. The molecules quenching your thirst could be older than our sun, forged in the heart of a dying star billions of years ago. This realization fosters a sense of awe and wonder about our place in the universe. It reminds us that we are not separate from the cosmos, but rather we are a part of it. The atoms in our bodies, including the hydrogen and oxygen in our water, were forged in the fiery crucibles of stars. We are, quite literally, stardust. This understanding deepens our connection to the universe and highlights the importance of exploring and understanding the cosmos. By studying water's journey through space and time, we gain a deeper appreciation for the interconnectedness of everything in the universe. Section 9. The future water's role in our exploration. As we venture further into space, the search for water will continue to be a top priority. Water is not just a resource, it is a lifeline that can determine the success or failure of our missions. Water is essential for human life, and finding it on other planets and moons will be crucial for establishing a sustainable human presence beyond Earth. It will be used for drinking, growing food, and even for creating a breathable atmosphere. Future missions like NASA's Artemis program aim to establish a permanent base on the moon. This ambitious project will serve as a stepping stone for deeper space exploration. Lunar water ice, found in permanently shadowed craters at the poles, could be used to support astronauts, generate rocket fuel, and even create breathable oxygen. This resource could transform the moon into a refueling station for missions to Mars and beyond. Looking beyond the moon, Mars is another promising target in the search for life beyond Earth. The red planet has long fascinated scientists with its potential to harbor life. Evidence suggests that liquid water once flowed on Mars, and vast reserves of water ice are locked beneath its surface. These ancient water channels and underground ice deposits could provide clues about the planet's past climate and its ability to support life. Understanding the history of water on Mars could help us determine if life ever existed there, and if it could potentially support human life in the future. By studying Martian soil samples and ice, scientists hope to unlock the secrets of the planet's past. The quest to understand water's journey through the universe is far from over. Water is a key ingredient for life, and its presence on other celestial bodies could indicate the potential for life beyond Earth. Each new discovery brings us closer to unlocking the secrets of our cosmic origins and the potential for life beyond Earth. The data collected from these missions will help us understand the distribution of water in the universe and its role in the formation of planets and life. And as we continue to explore the cosmos, water will undoubtedly continue to play a central role in our adventures. From supporting life to enabling deep space travel, water is the key to our future in the stars.